let us now look at this very simple problem. In this problem, we were playing a tournament where there's a winner and there's a loser. Who is the winner? We stop as soon as one of us, the winner, wins n games. So the two players are evenly matched, and so if you look at any one particular game in isolation, the probability that one of the players wins is exactly a half, and it's independent of all other games. Now the question is that what is the probability that the loser has won k out of those all the games that were played. Okay, so we're now interested in the case where the winner has won n games and the loser has won k games. Okay, so always the winner is going to be the one who wins the very last game. So if you list down the sequence of games, the very last game would have been won by the winner. Among the rest of the games, some games were won by the winner, some games were won by the loser. And out of all of these games, exactly k of them were won by the loser. And that's the event that we are interested in. We're interested in the event where the loser wins in exactly some k games in the among the first n plus k minus 1 games. Okay, so if you fix one such configuration, clearly the probability that you get this configuration is going to be nothing but 1 by 2 raised to the power n plus k. Why is that? Well, because there are a total of n plus k games played, out of which k were won by the losing player. But we want to ensure that those k losses occurred within the first n plus k minus 1 games, and we should account for the fact that any such subset of k games could have been won by the losing player. So which means that this is for one particular configuration. How many such configurations are there? Well, there is a total of n plus k minus 1 such games, out of which k have to be won by the loser. And so there are n plus k minus 1, choose k such configurations possible. And each one of them occur with this probability. So the final answer is given over here.